Hi, so let's get started with this question, two number sum. It's going to be covering all of those elementary concepts which you might have studied till now. I mean, they are the kind of like the prerequisites, right? And what I'm talking about is kind of like basics like the time complexities, using two for loops or using hash table and then so on. We can kind of check with that. And we are also going to be covering the approach termed as two-pointer approach within this problem itself. That's why I have written 3 methods plus code. So basically we are going to be seeing at 3 different ways to solve this problem, and then we can kind of code them all out. Okay, we can kind of code them out. Okay, so basically in the problem statement you will be given an array. In this case the array elements or the numbers are 3, 5, -4, 8, -1 and 11, right? And then you will be given a sum, or more importantly a target sum. So a target sum will be given, basically target sum in this case is 10, right? So you have to be finding two numbers from the array, right? Exactly two numbers, not 3, not 1, right? Exactly two numbers from the array, on the addition of which will give me this sum equivalent to the target sum. As simple as that. So basically pick one number, pick second number from the array and then add them up, right? So add both of them. And both of them, the addition, right? So the result of addition should be equal to the target sum. As simple as that. So in this case, I can see, right? I can see in this case that to achieve a target sum of 10 here, what I can do is I can just pick maybe elements like -1 and 11. In this case, in the array, these are the two valid outputs, or the valid outputs, right? So the valid answers. In this case, pick -1 and 11, and this is the output you should be given. This is the output you should be given. I mean, you should be given to the interviewer, not given. Okay, so this is the output you should be giving to the interviewer, right? Or the one who is interviewing you. So basically 11 and -1. So -1 plus 11 is nothing but 10. So 10 is equal to the target sum. As simple as that. I hope the problem statement is simplified. So let's get started with a few of the approaches. So the first approach is quite kind of naive approach, and you might have figured out by now, right? Let's see what the approach is. So the first approach is going to be utilizing two for loops, right? We will be using two for loops. So the time complexity will be kind of big O of n square, right? So n is nothing but the length of the array here, right? Consider n as the length of the array. So let's get started with that first approach. What I'll do quickly is I'll just move it a little upwards. I'll try to write the two for loops. So I'm going to be looping through the array twice. So for example, I have a current element 3. So I'll have a current element or a number 1 as 3, right? So a number 1, my number 1, num1 is 3 as of now. So once I have a number 3, I'll traverse the entire array from this onwards. So for example, this is the first indices 0, right? This is the first index 0. So I'll traverse the entire array from 0 plus 1. So I'll traverse the entire array from 1 to n-1, right? As simple as that. So in this case, my number 1 is 3. So what is the number 2 I should be having in the array? What is the number 2 I should be having in the array? It's as simple as target sum, right? So target sum minus number 1, right? This is a simple mathematical formula. So this should be 10 minus 3, which is 7, right? So 10 minus 3 is 7 and number 2 is 7. So I'll see that whether 7 is present in the array or not after 3 onwards, right? So I can see that 7 is not present. Again, I'll pick 5, right? So what do I need now? 10 minus 5, 5. Is 5 present up here? No, right? Okay, we move on. We pick -4, right? So what do we need now? So we need 10 minus of -4. So this is 10 plus 4, which is 14. Now I need a number 14 in the array after -4. Do we have such number? No, we don't have such number, right? So I'll move on, right? I'll pick 8. So what is the number required as of now? It's 10 minus 8, which is 2, right? 10 minus 8, which is 2. So I'll see whether 2 is in the array. I'll see whether 2 is in the array. No, there is no such number 2, right? So what I can do now, I pick -1, right? Here comes the magic part. I'll pick -1. So what is the number I'm left with, or what is the number I have to achieve now? It's 10 minus of -1, which is 10 plus 1, which is 11. I can see now that I can see now that the number 11, which is the required number or the required second number, sorry, so that's present here, right? So I can kind of print the output, right? So -1 and 11 is going to be my output, -1 and 11. I'll simply return this or print this, whatever the case is. As simple as that. What will be the time complexity? I can see that if I pick a number like 3, right, I'm traversing the entire array, so that's n. But again, I'm picking each and every number once, right, once. So I'm kind of traversing the entire array n times, and then again for each n, I'm traversing the entire array. So that's kind of like a 2 for loop. So that's why we will have a big O of n square approach. In this case, what is the space complexity? It's big O of 1, right? Big O of 1, because we are utilizing 0 space or no auxiliary extra space or no additional space. Perfect. Let's look at the other approach, right? So I'll just kind of remember or memorize what the array contents are. 3, 5, minus 4, 8, minus 1, 11. Okay, let's see how my memory game is. So it's 3, okay, 5, minus 4, it's kind of written right there. So 8, minus 1 and 11. Okay, let's get started. So this was the first approach, right? Kind of naive approach, big O of n square. Can we do better? Let's see. So the second approach is kind of interesting because it uses or makes use of hash table, right? It makes use of hash table. I'll just kind of green box this because this is the important data structure which we are going to use here. So what is a hash table actually? What is a hash table? Actually, I'll just write target sum here because you might tend to forget, or I even might tend to forget what was the target sum. So target sum is 10, right? And this is my kind of array. As simple as that. Now we will make use of hash table. So what is a hash table? Hash table is kind of self-explanatory, but I'll tell you what other programming languages support. So when I say hash table, in Python we have dictionary. In JavaScript you can have objects or memo. In Java you can have hash map. In C++ you can have unordered map, and then so on, right? So that's how you are going to be implementing. Basically what I'll be doing is I'll traverse the entire array only once. That's the beauty here. I'll traverse the entire array only once, right? Listen me, I'll traverse the entire array only once, and for each and every element I'll check if the other number required is in my hash table or not, and I won't check that other number is required or not. So basically what I'm trying to say here is, you might get confused by my words. So if I pick a number like 5, right, I'll pick a number like 5. So what is the leftover number I required? It's 10 minus 5, right, which is equal to 5. I'll check that is 5 in hash table or not. I'll check that is 5 in hash table or not. Earlier in this case, in the first approach, what we were doing is we were checking if the number 2 is present in the array or not. But in this case, we are checking that if the number is present in the hash table or not. As simple as that. So what I'm going to do, I'm just going to dry run through the example we are given with. I'll just kind of erase that. That makes sense. I'll pick the number first, which is 3, right? I'll denote hash table as hash kind of a thing, right? So hash, as simple as that. Now notice what I'm trying to do here. 3, right? So I'm at number 3. So my number one is 3. What is the required number? So my required number 2, right, is 10 minus 3, which is 7. I'll check now. Is 7 present in hash? No, right? If the number 2, 7 is not present in hash, what I'll do is I'll push in the number 1, which is 3 in this case, to the hash. So my 3 comes into the hash table, right? As simple as that. You can kind of write this value as 3 is true, or you can 3 is 1. Any one of those will do, okay? So in this case, 3 is true as of now, okay? But which means that yes, 3 is in the hash table. That makes sense. Let's proceed to the other one. So let's proceed to the second one. So my number one is 5, right? My number 1 is 5. What will be my number 2? It will be 10 minus 5, which is 5, right? So my number 2 is 10 minus 5, which is 5, right? I'll check that is 5 in array. No, that's not what I'm going to do in this case. I'll check that is 5 in my hash. No, it's not. So what I'll do, I'll push num1 to the hash. So my 5 is going to be true in this case, right? As simple as that. Now again, I'll just kind of erase all of these and then I'll try to do again. So my number 1 as of now is minus 4, right? It's minus 4. So what's number 2? Number 2 will be 10 of minus 4, which is 14. I'll check that is 14 present in hash. No, it's not. So should I push 14 or minus 4 to the hash? Again, this I have explained this for the two inputs. So I'll put number 1, which is minus 4 to the hash. So as of now, I'll kind of get rid of the ending here. So I'll write minus 4 true, right? As simple as that. So I'll just kind of enclose this here. Perfect. Now again, I'll move on to the next element. Okay, I'll move on to the next element. Let's see. We access 3, 5, minus 4. Now we are at 8. Okay, number 1 is 8. Required is 10 minus 8, which is 2. Right? Required is 10 minus 8, which is 2. As simple as that. Okay, my mic is working fine. 10 minus 8 is 2. I'll check that is 2 in hash. Is 2 in hash? No. So I'll push 8 into the hash as of now. So 8 is true. Perfect, right? Again, what I'll do as a part of our process, I'll move on to the next element. As simple as that. In this case, my next element is minus 1. Okay, my next element is minus 1. So what is the number I require, right? So the number I require is 10 minus of minus 1, which is 11. So I'll check now, is 11 in hash or no? No, 11 is not in the hash. So what I'll do, I'll push in minus 1 to the hash. So minus 1 is true as of now. Okay, as simple as that. Now I go on with the process, the usual process, the checking one. So now I have a number 11, right? So number 1 is 11. Number 2 will be 10 minus 11, right? What is required? It's 10 minus 11, as simple as that. That's plain maths, which I have been explaining for the first 5 elements, right? So number 2 required is minus 1. Again, I'll check here that is minus 1 in hash. Yes, it's there, right? It's there. I'll just kind of mark it with green. Yes, number 1 is in the hash. So in this case, I'll print 11 minus 1, or I can just reverse it or print minus 1 and 11. Any order will do, right? Any order will do. What is the kind of like, I can kind of like write minus 1 and 11 or 11 and minus 1. Any one of them will do, right? Over here as well in the first approach, right, you could write any ways. So 11 minus 1, minus 1, 11. So let's determine or let's analyze the time complexity. The time complexity TC is going to be big O of n, right? And the space complexity, here's the tricky part, the space complexity will be big O of n, right? What is the difference between this second approach and the first approach? The difference is we have a less time complexity compared to the first one, because in the first one we have big O of n square because we were using 2 for loops. In this case, it's big O of n, right? So consider the n value is 100, right? So the first approach will run at max in the worst case 10,000 times, right? If I'm not wrong. So that's 10,000 times. Perfect. And in the worst case, even in the worst case, the second approach is going to run for 100 times. You can kind of make sense here, right? The improve in the time complexity part. But talk about the space complexity here. That's where the problem comes in. In the first approach, we had a big O of 1 space. So big O of 1, which means constant space. We required no space. But in this case, we are using hash table and it's storing numbers at max big O of n, right? So it's kind of using big O of n space at max. So the space complexity here is a lot. In that case, there was none. In this case, it's big O of n. So this is a trade-off here. And we are only done with basically 2 approaches, right? First and the second. Let's get started with the third approach, right? So what I'll do is, I'll just kind of drag this thing here, the second approach here. I'll draw the array again. This is the third approach we are discussing. 3, 5, minus 4, 8, minus 1 and 11, right? As simple as that. And we had a target sum, right? We had a target sum, which is 10. This was the entire input snippet which we were given, right? As simple as that. What we are going to be doing in this approach, right, is we are going to be using the property of sorting here, right? In the question, you will be given that the array is not sorted. Okay, it might be sorted, it might not be sorted. That's something which the interviewer will say you or will inform you beforehand, right? So it means that we can consider that out of 10 times, 1 times it's sorted or 2 times it's sorted, and out of 10 times, 8 times, the 8 remaining times it's not sorted. So what I can do is kind of perform a sorting operation here, right? So I'll just kind of perform a sorting operation. So sort the array here, which will yield the array as minus 4, right? So I'll kind of write it properly so that it looks good. So minus 4, minus 1, we have 3, 5, 8 and 11, and I think I have covered every element. Minus 4, minus 1, we have 3, we have 5, and then we have 8, and then we have 11. Perfect, perfect, perfect. This is where the 2-pointer approach comes into play, or comes into the picture. That's why I said at the beginning that I'll be explaining the 2-pointer approach. Okay. So I'll be having 1 pointer. I'll kind of write the indices here, right? So I'll kind of write the indices, index, whatever you might call it. I called it indices at sometimes, index at sometimes. So that's 0, 1, 2, 3, 4, 5, y0 and not y1. Hey, that's elementary level thing. Array indexing starts at 0. Okay. So these are the indexes. Index, right? And this is the array kind of a thing. Perfect. We will have two indexes. The first one is going to be pointing to the left one, right? So left is going to be at 0 and my right is going to be at n minus 1. What is n here? Again, n is the length of the array. So length is 1, 2, 3, 4, 5, 6. 6 minus 1 is 5. So diagrammatically, I'll try to explain this diagrammatically. So diagrammatically, this is going to look like this. My left pointer is right now here and my right pointer is here. Okay. Or what I can do is I'll just write left is capital L and then right is capital R, right? So I've kind of abbreviated them. Perfect. And then what I'll do here is I'll just kind of write L and R so as to make it look cleaner. Okay. So right now L is here and R is here. Perfect. Left is here and right pointer is there. What I'll do is I'll compute the sum of the elements at both of these indices. So basically I'll be computing the sum as the sum of the array, array element at the index L, or which is left, plus the, so basically I cannot explain it properly, so I can kind of write sum is array of L plus array of R, right? It kind of makes sense what I was trying to say there. Excuse me. So basically we are going to be computing the sum here, and depending upon the sum we are going to be moving the left or the right pointer, or else we are going to be breaking out of the loop. It's as simple as that. Else we are going to do nothing. It's either one of those 4 possibilities. Okay, let's see. It's going to be either one of those 3 possibilities, to be honest. So let's see. So what we can do is I can compute the sum here. So L and R. What is the sum as of now? So sum is 11 minus 4, which is 7, right? So 11 plus of minus 4, which is 7. I'll check now. My target sum is 10, right? Just keep that at the back of your mind. So I'll check that is the 7 or the current sum. So CS current sum 7 less than the target sum. If it is the less than the target sum, then I'll move my left pointer to 1 step forward. So L plus is equal to 1 or left plus is equal to 1. As simple as that. Why am I not moving right pointer to forward? Because hey, that will result in, it might result in a larger sum or a smaller sum. But if I move my left pointer to forward, it means that it is guaranteed that I'll be having a current sum which will be kind of close to 10, right? So in this case, when my current sum turns out to be less than the target sum, I'll move my left pointer to 1 step forward. So what I'll do, I'll just kind of use a smaller eraser. I'll erase the left pointer and now my left pointer is at 1. As simple as that. Again, I'll compute the current sum. So basically it's minus 1 plus 11, which is 10. Now I'll check that is my current sum 10 equal to the target sum? Yes, it is. So I'll just break out of the loop, whatever the while loop, for loop, whatever I'm using, I'll break out of it. As simple as that, right? And that's where the process ends. One small case, or the third case, which this not covers, is what if the current sum is greater than the target sum, right? What if the current sum is greater than the target sum? What I can do in that case is basically I'll move my right pointer to 1 step backwards, right? I'll move my right pointer to 1 step backwards. As simple as that. So consider an example. I'll just kind of erase this. My bad. So that should be So initially my L is here, right? So initially my L is at 0, okay? And consider my target sum in this case is 11, right? My target sum in this case is 11. So I'll just kind of erase this and write 11, right? So in this case, my target sum is 11. Notice that the target sum has been changed, 11. Perfect, right? How do I achieve 11? I can see that 3 and 8 is 11, but approach wise I'll do, okay? I'll do step by step. I can see now current sum is minus 4 plus 11. So minus 4 plus 11 is 7. Is 7 less than the target sum? Yes. So what I'll do, I'll move my left pointer to one step forward. Again, I'll just kind of erase it, and then my left pointer will be at the 1th index. As simple as that, right? I think you all agree with me as of now. So let's proceed. Again, I'll compute the sum. So minus 1 and 11, minus 1 and then 11. So that's 10, right? Is 10 less than 11? Yes, it is. So again, I'll move one step forward. Okay, I'll move one step forward. So now my left pointer or my left pointer is going to be at the index 2. As simple as that. Again, I'll compute the sum as of now. Again, I'll compute the sum. So what is my sum? What is my sum? So my sum is 3 plus 11. So 3 plus 11, which is 14. I'll check, is 14 less than 11? No, it is not. Is 14 equal to 11? No, it is not. So these are the two conditions which I covered with the target sum 10, right? When I was explaining with the target sum 10. But as of now, we came across a third condition, or the last condition, which is if 14 or the current sum, CS current sum, not computer science, but current sum 14 is greater than the target sum. In that case, I will move my right pointer to one step backwards. Okay. So my right pointer is going to be at the 4th index, right? So my right pointer is at the 4th index. I changed the color. As of now, it doesn't matter. So my right pointer is at the 4th index. Okay. Now I'll compute my sum again. So my sum will be 3 plus 8. 3 plus 8 is 11. And again, this kind of matches with the second condition, which is 11 equal to the target sum? Yes, it is. So I can print 3 and 8 in any order. So I can print 3 and 8, or return 3 and 8, or 8 and 3. Any order would do. And these are all the 3 different ways by which we can solve this problem. Again, the time complexity. Well, the time complexity here is quite interesting. I'll kind of erase or get rid of majority of this because here I've explained the process. So let's analyze the time complexity. It's a little trickier. So time complexity TC for sorting an optimal sorting algorithm like a merge sort or quick sort, right? In this case, I'll use a quick sort because hey, merge sort requires big O of n extra space, right? So in this case, my time complexity, if I use a quick sort, right, or a dot sort in Java or Python is known as a tim sort. You can kind of check that over the internet, right? So you can check tim sort. It's a good sorting algorithm. So the sorting algorithm, which we write it like this, right? So ARR dot sort. So this dot sort kind of implements tim sort internally. Okay. So tim sort or the time complexity as of now is going to be n log n, right? But that's for sorting, and for traversing the array once, that should be big O of n. So plus n. And we all know that this can be simplified to big O of n log n because n is that smaller part, right? So what I'm trying to say here is, what if I have something like this? What if I have something like this? So if I have n square plus n, right? N square plus n, then this can be written as what? This can be written as big O of n square, right? We are kind of neglecting the smaller part. That's what I'm trying to do here. What I'm trying to do is basically n log n plus n. So my time complexity is basically big O of n log n, big O of n log n. As simple as that. What is my space complexity? Well, we have not used any space, so that's big O of 1, right? So that's the entire approach. What if I had to say to the interviewer that which one is the optimal one? Again, it's the matter of trade-off. If the interviewer says, or the one who is interviewing you is saying that, well, you have to optimize the time and the space complexity both, then what you can do is you can pick the third approach, n log n and constant space. What if he says that you have to have the best time complexity ever? Then you can pick the second approach. He is not mentioning about the space complexity. He is talking about the best time complexity. So pick the second approach, big O of n, the best time complexity, right? As simple as that. So I think the explanation part has been done. I'll just kind of move to the coding part here. So I'm coding in Visual Studio Code. I've created one file. It might not be visible as of now, but it's 2numbersum.py, right? .py because I'm going to code in Python so that you can convert into your favorite programming language. So let's get started. So basically what I'll be doing is kind of simply creating one function called solve, right? Solve, and then which is going to take two parameters, array and the target sum, right? As simple as that. Now I'm trying to code the first solution. So this is the first approach, as simple as that, right? So this is my first approach. Now what I'll do is I'll kind of write two for loops here. So for I in range, I'll just kind of declare something like n is the length of the array here, right? And I'll just kind of check simultaneously because it kind of stops the recording at some point of a time. Perfect. So for I in range n, right? So for I in range n, that's my first for loop. So my number one is going to be array of I, right? Now I'll use my second for loop. So for j in range I plus 1. Why not I? Because I'm not going to consider a number twice, right? So if I'm at number 3, I won't start with the number 3 again. I'll start with one index greater because that makes sense here, and that's what something we have discussed. So my number 2 as of now is array of j, right? And then I'll check that if number 1 plus number 2 is equal to my target sum, right? If it's equal to my target sum, then I'll kind of return. Why return? Because this is a function, right? Solve function which I'm trying to solve here. So return something like number 1 comma number 2 because the sum of these two numbers are equivalent to target sum. Else what I'll return? Else I'll return false, or I can just write false, which means that hey, my answer does not exist, right? So this was the first approach. Let's try to code the second approach. So this is going to be my second approach, which I'm trying to write here. So this is define solve kind of like 2, right? And this was solve 1 because this was the first approach. Solve 2, it's going to take parameters like array and then target sum. Also, these are not known as parameters. When I'm trying to write the function, it's known as arguments. When we are passing them to a function, it's known as a parameter. Some terminologies here and there just to make you clear. So solve 2 array target sum. The second approach was using a hash table, right? So I can just kind of write hash, or maybe I can just write memo, right? Memo. It's an empty dictionary as of now, right? Memo is an empty dictionary as of now. So what I'll be doing is I'll kind of run a for loop, right, inside of an array. So that's going to be for I in range n, right? So for I in range n, and again n is kind of undeclared here. So what I'll do is simply write n is equal to length array, right? I'll just kind of be range n, and then I can kind of pick the number 1 here. So number 1 is nothing but array of I, and the required number which I'm going to check in memo, right? The required number which I'm going to check in memo is nothing but number 2 is going to be target sum minus number 1, right? Target sum minus number 1, as simple as that. Now I'll check that if number 2 in memo, then in that case I'll return as simple as number 1 comma number 2, right? As simple as that. And if the return condition never satisfies or never gets caught, then in that case I'll just simply return false, right? This was our second approach, and this is something which we have discussed, right? Also, I missed something here. So I'll check that if number 2 is not in memo, right? In that case, this is the else part, that the number 2 is not in memo, right? I can even just write else there, but I'm commenting it out. Then in that case, memo of number 1 is going to be true. That's what I have been doing the entire time in the explanation, right? Then here comes our third approach. So this is the third approach, the one with the sorting 1 approach. So define solve 3, and then we will have array and our target sum will be there, right? So basically what I'll be doing is I'll first sort the array. So array dot sort, right? I'll maintain 2 pointers here. So I'll just first kindly kind of like write n is the length of the array here, right? And then I'll maintain 2 pointers. So left is at 0 and my right is going to be at n minus 1. As simple as that. Then I'll kind of use the while loop property here. So while left is less than right. As simple as that. I don't want to cross mix the left and right here because that will distort the property of array, right? What if the right is at index 2 and left is at index 5? That won't make sense, right? So while left is less than right, while left is less than right, current underscore sum in that, and the explanation I used to write it as CS, right? So just name the proper variable. So current sum is going to be array left plus array right, which is nothing but the element in the array or the number in the array at the left index and the number in the array at the right index. Sum them up. That's my current sum. I'll check that if my current sum is equal to my target sum. Well, that's the bingo thing, right? I mean, I just found out the numbers. So return simply array of kind of like the left number and then the right number, right? As simple as that. Elif, I'll check that if my current sum is less than my target sum. What will I do in that case? I'll do left plus equal to 1. Again, I've discussed the intuition why I'm doing left plus equal to 1 and not right minus 1 in this case. And then if my current sum is greater than target sum, that's the last part. So I'm just writing else. Then in that case, right minus equal to 1. Right? I think it's past 2 p.m. as of now. I mean 2 a.m. So I think this is it, right? So this is it. And if I don't encounter this condition, right? So return array left and array right. In that case, I'll just write return false. As simple as that. I'm not dry running the code as of now because, hey, we are just kind of solving the function here, right? And that kind of makes sense. Even if I want to do that, I can just kind of do here. So I'll just write, if I want to solve it using the third one, right? So I'll just use it, third one. I'll pass in an array. For example, I'll just pick in the array which we had in the open board. So it's basically 3, 5, minus 4, 8. Okay, 3, 5, minus 4, 8. 3, 5, minus 4, 8. So I'll just write 3, 5, minus 4, 8. And then we had minus 1 and 11, right? Because that's what I want. And then we had 10. Okay, this was the kind of like the input we had. Control S to save, and then I'll kind of write here Python 3, and then we'll have the name here. So 2numbersum.py. Okay, it's not returning anything, right? Let me check what's wrong here. Maybe I can just simply write here print, right? Hope that makes sense. Print this much. Let's see if that works. So Python 3 2numbersum.py, it works. So minus 1 and 11, right? As simple as that. What if I had something like I had to achieve 13, right? And I want to do it using the second approach, right? I want to do it using the second approach. Again, I'll just save that and then I'll kind of clear this up, clear the mess up. I'll write Python 3 2numbersum.py. Let's see what our output is. 8 and 5. So 8 plus 5 is 13. As simple as that, right? So I was not trying to run this thing because, hey, that's self-explanatory, and I believe you can even do that if you have watched the video till now. So these are the three definite ways to solve this question. You might come up with other ways, but more or less the concept is going to be the same. So I hope the video was helpful and informative, and if you like the video, so make sure to subscribe and follow. And I also have one Instagram page where you can, I'll just link it in the description. You can kind of check there as well for any video updates. So let's meet in the next video with another interview question. Thank you.